Hello, in this video we are going to learn about multiplying polynomials, specifically binomials, and I'm also going to teach you that vocabulary that I probably should have taught you a couple weeks ago. So these are a whole bunch of words based on this root nomials, these are overly fancy words for a not super complicated thing, but it sounds complicated when you describe it. So we have a monomial, which is just something like 2x or 3x squared or y. It's just whenever you have like a single chunk of stuff that's related only by multiplication and division. So actually this could be like y over 2, for example. A binomial is when you have two things being added together. So 2x plus 1, 3x squared plus 4x, or y to the 5th minus 3x. Those are all examples of binomials. This is not a very strict category. It just means there's two things that are being related by multiplication or by adding or subtracting. And each of those things is a monomial. And then you could even have a trinomial, which shockingly enough would have 3 terms being added or subtracted together. So you might, or 3 monomials being added or subtracted together. So 6x squared plus 3x plus 1, or 19x to the 5th minus y plus x. I don't know, I'm just throwing stuff out here, right? The only requirement is that it has 3. 1, 2, 3. 1, 2, 3. Okay? Now we're mostly going to be focusing on binomials. Trinomials we're going to see all the time when we do quadratics, and that's kind of where a lot of this stuff is building up to. Okay? These are all examples of polynomials. Okay? Poly just means it has multiple. Alright, so now, in class, we were looking at how to use algebra tiles to multiply mostly binomials. That's what we were looking at. So let's take an example. First, we are now going to multiply binomials. Let's say that we're trying to do x plus 3 times 2x plus 1. Now, I was trying to help us understand what's really happening here by using algebra tiles. So we know that we're going to need to have an x plus 3 on one side, and we're going to need to have a 2x plus 1 on the other. So that would mean there's going to be probably an x and then a 2x. On this side, I'll need to have a 1. On the other side, I'll need to have 3. And then I have to kind of fill in the pieces. Alright, so I use the rest of my tiles to fill that in. I've now got some spots for some 1s there, so I'm going to grab 3 1s. And there I have, oops. On this side I have my x plus 3. On my other side I have, that's really not legible at all, I'm sorry. Let's try again. X plus 3 is over here because this is an x, and then 1, 2, 3. Over here I have 2x plus 1. Okay? So, and then that means my answer would be, I just count up all the stuff inside. I've got 2x squareds, got 1, 2, 3, 4, 5, 6, 7 x's, plus 1, 2, 3. Notice, what type of number is this down here? A trinomial, perhaps? It's true. When you multiply two binomials, sometimes you get a trinomial. All right, now, there must be an easier way. right? We're not carrying around algebra tiles with us. We are doing this sort of calculation all the time without needing this visual. So what we're going to do is we're going to figure out a way that we can model this without needing to actually break out the tiles. All right? And this is where that generic rectangle that came in to the problem set unintentionally earlier this week comes in. So we're going to draw kind of a model of what this looks like. And I'm just going to make it, like, they call it a generic rectangle. I'm going to draw it like it's a square, even though I know this isn't actually a square. And then I'm going to label the sides. So I'm going to say that this part right here is going to represent that 3 there. So I'm going to label it as 3. This side right here is going to represent the x. I know these numbers because I'm looking up here. I'm looking at x plus 3. And I'm putting the x here and the 3 here. Then on the bottom side, I have a 2x plus 1. So I'm going to put 2x plus 1, 1 plus 1, 1 plus 1. And then I can multiply each of my pieces. So my x times 2x, that gives me 2x squared. I can see that right here, right? It gives me 2x squareds. But I also know that x times 2x does in fact equal 2x squared. I can do for the top up here. This whole chunk right here is what's being represented by this box. So that's 1, 2, 3, 4, 5, 6. 6 x's. And look, lo and behold, 2x times 3 does in fact equal 6x. I'm going to do this those tiny little 3 right there. That's being represented by this box right here, because that's 3 times 1 is 3. And then this single unit along the side there, that's being represented by the x times 1. And so that gives me 1x. Now, this does not look like that yet, right? So what I need to do is I'm going to write out these pieces. I'm sorry, this is kind of messy this time, guys. 2x squared plus 6x, I'm just writing out my terms, plus 1x plus 3. And then when I simplify that by combining like terms, 6x plus 1x would give me 7x. I get 2x squared plus 7x plus 3, just like what I had up top. All right, let's try it. So we've got x minus 6 times x plus 5. I'm going to multiply these, and I'm wanting to get like the inside, what quantity of tiles made up the inside. But I don't actually want to use tiles. I want to use a generic rectangle instead. So I'm going to draw my generic rectangle. You're going to do this too. And I'm breaking it up into 2 pieces on each side because these are both binomials. They both have 2 terms. So one side I'm going to label as x and then a negative 6 because I have a minus there this time. And then the other side I'm going to label as an x plus 5. And then I'm going to fill in my pieces. So I'm going to do each side of multiplication. So x times x, that gives me x squared. X times 5 gives me 5x. X times negative 6 gives me negative 6x. And negative 6 times 5 gives me negative 30. I'm then going to rewrite my terms. X squared plus 5x minus 6x minus 30. And I combine like terms. So x squared, that can't combine in with anything. Negative 30, that can't combine with anything. But the 2 x terms can. 5x minus 6x, that's just a negative x or a negative 1x. So my final answer is x squared minus x minus 30. Let's do it again. This time I want you to try it on your own first. You are going to do negative 2x plus 1 times x minus 5. Please pause, draw out a generic rectangle, and then come back and check and see if you got it right. Did you start by setting it up like this? And then did you fill it in like that? And then when we simplify, 10x plus x should give us 11x. So negative 2x squared plus 11x minus 5. All right, for your practice problem, I want you to try and multiply x plus 9 squared. Now, before you say, wait, Miss Sherman, that's not at all what this video is about. It is. Because remember, this is the same as x plus 9 times x plus 9. Go ahead, give it a shot.